This is Danny Tang. I'm doing the probability and stochastic processes homework 10, problem 2. Problem 2 asks us to find mean and variance of x of 8. And this is the same Poisson process as we did in part 1. So given that expected value of x of t, where t is 9, is equal to 6, we can find what lambda is, so we can use lambda in the rest of the question. So we know that expected value of a Poisson process is lambda times t, and t is 9, so 9 times lambda equals 6, and lambda is 2/3. So in part A, we have to find expected value of x of t when t is 8. And we just write this out, lambda times 8 equals 2/3 times 8, which is 16/3. So, and the variance is the same thing, it's just lambda times t. So you get the same for expected value and and the variance of x of t when t is 8. Part B asks us to find probability of x of t when t is 2 is less than or equal to 3. And for this one, we have to use a summation because we want to find the cases where from 0 to 3, because this is less than or equal to 3. So we use this summation formula, which is given to us in part 1, and we know t is 2, so, and we know that lambda is 2/3, so we just basically put this in the equation, in the summation. And so we have to do it for 4 cases when n is 0, n is 1, n is 2, and n is 3, and then we have to add it all together. So basically you get this this expression here, which is simplified, which is e to negative 4/3 times 1 plus 4/3 plus 8/9 plus 32/81. And this whole thing equals approximately 0.995, if I'm not wrong. So, 0.955, sorry. So in part C, we're given the conditional probability where x of t when t is 4 is less than or equal to 5, on the condition that x of t when t is 2 is less than or equal to 3. So to do this one, we have to use dummy variables. We can set x of 2 equal to a, and x of 4 minus x of 2 equal to b. And we know that a and b are independent because they're non-overlapping. So the two random variables are independent. And they have the Poisson parameter 2 times lambda because because the intervals are from 0 to 2. And so t2 minus t1 is just 2. And same thing for the interval 2 to 4. So to do this, we take x of t when t is 4 less than or equal to 5. We subtract x of t when t is 2 on both sides, and then we get this expression here, which is x of 4 minus x of 2 less than or equal to 5 minus x of 2. And then using the dummy variables we created here, we substitute b for the left side and then a for x of t when t is equal to 2. So then you can rewrite this expression as a probability of b less than or equal to 5 minus a on the condition that a is less than or equal to 3. So then we can rewrite this conditional probability as an intersection here over the condition of probability of x of t is when t is 2 less than or equal to 3. So this is just definition of conditional probability. And then we substitute in the dummy variable, so you can rewrite it like this. So then the expression is just probability of b less than or equal to 5 minus a intersected with a less than or equal to 3 all over the probability of a less than or equal to 3. And we already found this in part B, and that's 0.955. So for the numerator, we can just write a double summation expression here, Since we can't really evaluate this, we just put this whole expression over 0.955, and that's it.